Hello all, I'm Siddharth Kaul and I welcome you to Edupedia world. In this video, I'm going to give a brief introduction about MATLAB classes. There are many different data types or classes that we can work with in MATLAB software. We can build matrices and arrays of floating point and integer data, of character and strings, and logical true and false states. Function handles connects our code with any MATLAB function regardless of the current scope, whether it is local, whether it is global, or it's interfile. Then we have tables, structures, and cell arrays that provide us with a way to store dissimilar type of data in the same container. So there are basically 16 fundamental classes in MATLAB. Each of this class is in form of a matrix or an array. With the exception of function handles, this matrix and array is a minimum of 0 by 0 in size, and we can grow it to n-dimensional array, n-dimensional size. A function handle is always scalar, that is 1 by 1. So all of the fundamental classes are shown in the diagram. So I will take a minute here to explain this tree. So starting from the left, we have classes of which we can make matrices and arrays. We have logical class only deals with the true and false states. True and false states of data means they only have true and false or arrays of binary data. We have character class that have string arrays and character groups. Then we have numeric class that has all types of single, double, and integer data types. Then we have table class, cell class that are nothing but containers, but they can have variety of objects under a single variable. And then we have a structure class that can have certain mannerism in which we can store object of other classes. Numeric classes in MATLAB software include signed and unsigned integers. It also includes single and double precision floating point numbers. By default, MATLAB stores all numeric values at double precision floating point. Remember that we cannot change this default type and precision. We can choose to store any number or array of numbers as integers or a single precision. Integers and single precision arrays offer more memory efficient storage than double precision. So all numeric types support basic array operations such as subscripting, reshaping, mathematical operation, algebra, all that. We can create two-dimensional double and logical matrices using one of the two storage format, full or sparse. For matrices with mostly zero-valued elements, a sparse matrix requires a very small amount of storage space as compared to what is required for an equivalent full matrix. Sparse matrices invoke methods especially tailored to solve sparse problems. These classes require different amount of storage, the smallest being a logical value or 8-bit integer which requires only 1 byte. It is important to keep this minimum size in mind if we are working on data in files that were written using a precision smaller than 8 bits. So let us look a little detail for each of the class. So let us start with the default numeric class in MATLAB, the single and double class. These classes come under, of course, as I said before, numeric class of MATLAB. This, as we know, are required for fraction or fractional numeric data. The single class deals with the single precision and the double class deals with the double precision data. The double precision data is the default data. We can know the limit of maximum real number our computer can handle by typing the command real max. We can also know the limit of the minimum real number that our computer can handle by typing the command real minimum. These extreme numbers varies from machine to machine. The two-dimensional arrays that we use here for single and double precision can be sparse. Sparse, what is sparse? Sparse is a matrix when most of the elements are 0. So what is the use here? What is the use of sparse here? The use of converting a full matrix to sparse matrix is just to save memory. In simple terms, if most of the elements in a matrix are 0, it makes sense to save data space and hence it is converted to sparse matrix. So both single and double precision class supports these sparse matrices. Also, I will repeat this that also I mentioned this earlier and I will also repeat this that the default numeric type in MATLAB is the double. So by default all variables will have the data type of double. Integer class. Another class that comes under numeric class is the integer class. When using integers, it is required to explicitly define a variable as an integer. The integer class supports both signed and unsigned numbers. These classes are known to be more efficient in use of memory as compared to single and double. We can know the integer's maximum limit that our PC can support by typing the command integer max, and we can also know the integer minimum limit that our PC can support by typing the command integer minim. Integer class supports 4 sizes, that is 8, 16, 32 and 64 bits. Character class type. This is the class that is responsible for all data types that deals in characters. Using this, we can use it single character or matrix of characters. This is a native character class. MATLAB supports easy conversion of character type into numeric type and from numeric type to character type. Conversion can be done by calling the appropriate function. These are the characters that we use to build regular expression. For multiple strings or multiple character arrays, we use cell arrays as containers. Logical class type. This class comes into picture when MATLAB is doing state checks and relational conditional check. Say for example, if we say is A less than B, then MATLAB recognizes the relational operator, and after the operation is performed, the output of the state is logical answer, that is either a true or a false. This class can only have two values, true or false. No other value is supported. So we can say that the data type is Boolean. Like the numeric class, it also supports sparse arrays. Function handle class. As the name suggests, this class is there to handle the pointers to the functions that are called in the MATLAB. It basically stores a pointer to a function. Due to this, it is able to pass a function from one function to another. This allows us to bend the rules of scope of function, and using this we can call a function outside its scope. This is a pretty cool feature. Say for example, we are having a local scope of a function and a global variable that stores the pointer to this local function. Even though the function has local scope, we can use the global variable to call the local function from outside its scope. This feature is used most prominently in handling the graphics callback in MATLAB GUI. Table class. So this is a container which can have mixed type data but column oriented data. Using the row and variable names, we can identify the components inside this class. We use the properties of table to store the metadata such as units of variables, scaling for the variables and many more. We can also manipulate the data inside the table class in the same way we do for numeric class or logical class. We access the data inside the table using numeric or named index or using both. We can create n number of tables from a single base table just by extracting the data. So basically we are creating subsets for our major set. Structure class. Structure class can store arrays of various classes and sizes. There is basically no limits in how many kinds of classes it can store or what size of data it can store. It has field inside the class. So when we access the field of structure, we are indicing all the data in that field in single operation. Field names are used to identify the content stored in structure. We commonly use this to pass the arguments to a function in case a function has many input arguments. This makes our calling function look less cluttered. Also, if you remember comma separated list, the list is where we use the structure the most. Obviously, as it supports multiple classes and sizes, the memory it occupies is also more. So initially more memory is required for it. Cell class. Cell class is this class that stores arrays of various classes and sizes. Again, it is similar to structure. This kind of storage allows freedom to package data as we want. Another perk is that manipulation of cell remains similar to that of numeric class or logical class. This, like structure, cell classes are used to pass arguments as input to functions, making the calling function look less cluttered and making the manipulation of argument value very simple. This is also used in comma separated list. Like structures, it stores various other classes of all sizes. Hence the memory requirement is more for cell. Hence initially the memory overhead is very high. This concludes our video, and this gives us a brief introduction about MATLAB classes. In the next video we are going to deep dive into numeric classes. So until then, Please subscribe and thanks for watching.